Hello everyone, this is Srima and welcome to Genius Mathematics. In this video, we will see all about circles and sectors. First, we will see the pi, what is the pi constant, and then we will see circumference and area of a circle, and then we will go to sectors. First, we will see something about circles. So, a circle is something that has no sides or no corners. So, and it should be equal in all the region, that is from the center to all the points around the circle, it has to be the same, that is the radius r. So the center point is usually denoted with O, that is for origin. So that is how we will denote a circle. So this region is called the perimeter. Like any other shapes, the outer line for square, it is like the addition or sum of all these sides is called the perimeter. But for a circle, the word is little different. It is denoted as circumference. So circumference of a circle is the distance from, let's say, here around the circle and then back to here. So this is the circumference of the circle. And this is the radius as we see here. Now, a line that crosses between the midpoint or the origin and comes back to other side is the diameter. So this is also r. This is r. This is also r. So this becomes 2r. So 2r is the diameter of a circle. Now another thing about circle is this line is called a chord. That is CHORD. So the definition of chord is you take any 2 points on a circle. Let's take this point and this point. And if you join these 2 points with a line, this is called a chord. But this is not a diameter because it does not pass through the midpoint, that is the origin. So this is a chord. But is the diameter a chord too? The answer is yes. The diameter is also the chord because it is just starts from this point and ends to the next point. That is the definition of the chord. So the diameter is also a chord. But all chords are not diameter. So in a circle, the diameter is the greatest chord because it is the biggest distance. It is the lengthiest of all the chords. And this is not the only diameter. A circle has infinitely many diameters. So this is the thing with chord, diameter, radius and circumference of a circle. Now there are formulas for finding all these. First we will see the radius is just the distance from the midpoint to any point on the circle. So this is the radius. So that's with radius. And for diameter it is like the chord but that passes through the center. So that is the diameter. Now for the circumference, the formula is 2 pi r. We will see what this pi is in a little bit. So the formula for circumference is 2 pi. These two are constants. The only changing part is radius, r. So that is the radius. So the distance around the circle is given as 2 pi r. So it depends on the radius of the circle. Now for the area it is pi r square. Again the constant again appears. And here the radius is square. So this is again the radius. So the area also depends on the radius. Now we will see the constant pi. So you take any circle. Let's say we have a circle with radius 5 cm. And let's say you have another circle with radius 7 cm. So if you just stretch this circle in all direction, or if you just expand this circle in all direction, you will get this circle that is of 7 centimeter radius. And if you shrink this circle in all direction, you will get this circle of radius 5 centimeter. Let's say you have a triangle 3, 4 and 5 centimeter like this. If you stretch it, or if you shrink this as 4, 2 and 3, this is not similar to this, because you have shrunk this in all ways, but the similarity properties of triangles does not meet. Let's take another simpler example. Let's say you keep these sides as the same, and if you just extend this, let's say 6, these two are not similar because you have just extended in one side of the triangle. So these two are not similar triangles, although they are triangles. But if you compare this with circles, you cannot extend a circle in one direction. Like you cannot extend the circle in one direction, or it will become ellipse. That is another shape. So that is the important thing about circle. You cannot extend or expand the circle in a singular direction. You have to expand in all the region. So that's why a constant comes, that is pi. So what this constant means, if you divide the circumference of any circle of any radius by the diameter, it equals the constant pi. That is, you know the circumference, that is 2 pi r. You also know the diameter, that is double of radius, so that is 2r. If you cancel this, you get pi. So why this works is, all circles are similar to each other. Just divide the circumference by the diameter, you will get the constant pi. So this is why circles have a constant region. The circles have a constant value of pi. So this is the thing with pi constant, circumference and area of a circle. Now the next thing is sectors. It is like a subcategory in a circle. Let's take a circle. So this is a radius. Let's take radius r. If you take another radius, this is also equals r, because from the midpoint to the any point on the circle you have taken. So this is also r, this is also r. So what is the length from here to here? If this is a straight line, you can just have a scale and measure this. But this is a curve. So how do we find the length of this? So the name of this thing from here to this is called arc. So this we have theta, the angle between this line and this line. So arc. Now the length of this arc, that is from here to here, is given as S equals r theta. Here S is the length of the arc, r is the radius of the circle, and theta is the angle here. So this is the form I have to know to find the length of this area here. So this part of the circle is called a sector. Just to take a slice of a pizza, something like that. So this area, this shape is called the sector, and this is called the arc. But we have actually drawn two arcs just by two radius. That is, this is called the minor arc because it is of smaller size compared to this major arc. That is this arc. We have also created this arc along with this arc. So this arc is called the major arc because it is of larger distance. So this is a minor arc and this is called the major arc. So now, what is the area of this sector? That is, you know, the area of a circle is like area between this part. What is the area of this sector? there is a formula for that. Area of sector equals 1 by 2 r square theta. So this is the area of the sector, half into radius square, we know the radius r, and theta again we utilize this angle. Now the interesting thing is we can actually derive the area of the circle just by this formula. That is 1 by 2 r square, this is the area of circle, half r square, and theta for the whole circle, the theta is 360 degrees. So apply 360 degrees. If we want to convert this into radian form, we can do pi by 180 degree. Don't forget the degree. So if we cancel these two, we get 2. And we can cancel these two and we got pi r square, which is the area of the circle we found out earlier. So the area of the circle can be found out by area of sector. Now the another interesting thing is the next thing, that is from length of arc. What is that? That is S equals r theta. From this we can find the circumference of the circle because the arc is a part of the circle. So for finding the circumference, just utilize this formula, that is r times theta. Now the theta part again is 360 degrees. Again converting this into radian, we get r, thus cancelling, that is we get 2 pi r, which is the circumference of the circle. That's how we derived the circumference of the circle from the length of our formula. Now that's the thing with circles and sectors. Thank you.